All right, as promised, I want to walk you through homework number 7 in this video. I have about a half an hour in which to do it, so I need to be efficient with this while still being detailed enough so that you know how to do exactly what you need to do for it. So it's up already on the course webpage, even though I'm still waiting for your homeworks number 6. Never fear though, there's still plenty of time to work on this. It's up here in PDF format. It's due on Friday, October 29th. And for this, I not only want to make sure you know how to run a signal detection theory analysis for real data that you might get from a speech perception experiment, but I'm also going to take the opportunity to try to teach you how to do R scripting, which is basically feeding a series of instructions to R and executing them automatically so that you can kind of save yourself a lot of typing work. And then R will spit out the results of the commands to you so that you can essentially save a lot of time if you have a lot of data to process. And I guess I'll put this in context as well by saying that in the old days, up until 2 years ago, I used to always have people work on this exercise using Excel, which is a little bit less than ideal because I want to keep it all R focused for this class. But the tricky part is that doing it in R is involved. And that's why we're learning R scripting here, to basically save you a bit of time and then hopefully also accomplish an educational goal along the way, which is to give you this super powerful tool of knowing how to do scripting in R. So the goal is to make our lives a little bit easier. You may not think that's the case as you go work through this homework, but be that as it may, you're still going to have to do it. And like I said at the beginning, there's a lot of details in this exercise. We need to know them all, so I'm going to try not to rush through them too quickly, but just make sure you understand all the details because it all fits together in the end, basically. So an R script is just a series of R commands that you can store in a file, and it has to be a text file. And then you can have R run those commands on demand, and by the time you're done with this exercise, you'll be doing exactly that, and you'll see how much easier it will make your life. Working with scripts can be useful if you have to work with a set of commands that are more intricate or complicated to execute than usual, or scripting can just be helpful if you want to keep your R work looking nice and tidy and stored in a convenient place that you can easily access later. Either way, working with scripts and using scripting language can take a little while to get used to, it takes a little while to get used to R itself. So what I want to do here is start off by showing you where you can download the scripts that we're going to play around with in this homework exercise. There's 2 different versions of the script that you're going to have to work on, and one of these has comments and the other doesn't. So this is the kind of raw version, I guess you could say, where it just has the commands. And these all look like R commands, right? They're ordered throughout the document. There's just a lot of them. Like I said, there's a lot of details in this exercise, but don't fear too much because I have actually done all of the heavy lifting for you, or not all of the heavy lifting, but most of the heavy lifting for you. And you need to do just a little bit of work on top of that to get the results that you're looking for. You can compare this script, and its name is sdtscript.r, like this. And there's also this version with comments, like this. Both of these have a .r extension so that R knows how to find that script when you open it. And one has comments and one does not. What comments mean is that at the beginning of each line in the script, I can add these 2 sort of hash marks or pound signs or whatever you want to call them. And then I can make a comment, which is just a normal natural language comment to myself or whoever reads this script about what's going on at this particular point in the series of commands that we're trying to execute. So for instance, the first command that you employ in this script is the sync command, which is a really funny word for R to use, but basically what this does is it opens up a file called homework7results.txt, and it just puts it in whatever your working directory is that you're playing around with in R at that particular moment in time. Yeah, so normally I'd think of this in the programming language I normally use as like open, but in R it's sync, and that's all it's doing is it's creating that file. And then it's going to take the results of your commands and stick it in that file once you're done. With that in mind, I want to go to my R console here and go to the appropriate working directory. For me, it's in my teaching folder and my Lingstats folder. It's homework number 7. And I've already saved these scripts to this directory because I've been, pilot testing this script before I make this video. So they're already there, but what you should do is go to these links on the website and save them in a similar directory here in which you'll do your work for this homework. So that way, when you run the script, it can easily find the information it needs, which is going to be in this sdt.txt file. And then it will also make a results file in the same directory, so you don't have to worry about where to find it or anything like that. So I'm just going to navigate. I'm changing my working directory to this particular directory. And the third thing that we just saw there is that there is a data file. Whoops, this is not what I want. There is a data file here, which is online, and you can download it to your hard drive as well. So we'll put that up there. And this is the raw data from the experiment that I was talking about at the end of the SDT lecture. So all these are up online on the course webpage, and I would recommend that you download them all and save them in that same directory that you're going to be working in for this exercise, which is the point I've made right here. If you can see that. I'm messing around with this. There we go. Okay. And so this point says, so first time I tried this was 2 years ago in the 2019 class, and I kind of made a big deal walking through it together with everybody in class. We don't have the luxury of being able to do that this time around, but I think it worked reasonably well last time, and I think it can work well again this time because I'm making a video and you can refer to this and look through all the little details as you watch it. But it will require you to do some grunt work and pay a lot of attention in order to get it to work. So that's why I want to walk through it with you. I wouldn't recommend fast forwarding through this video too much, in other words. I've already talked about this. One of the scripts has comments, one of the scripts does not. We don't need to worry about that so much anymore. I'm going to, for your sake, work with the script that has comments, though, so that you have a better sense of what's going on in it. As somebody who knows what's in it, I can deal with all this information no problem. Once you get to that point, you can do the same yourself. But I know that coming back to this exercise for the first time after 2 years, it helped me a lot to be able to see these comments because it takes a while to just get a sense of what's all going on in it. Okay, there are 2 important instructions that I need to give you so that you can actually use the script when you need to. To open the script on a Mac, you first open up an R console, and then you can simply go through File, Open Document, like this, and it's going to spit me right into the working directory that I have here, and I can just double-click on script, SDT script with comments.r. And this will look exactly the same as what I've seen here on the website. It's got all these comments and commands working together for the greater good of humanity. Okay, so you can also open up just double-clicking it on your hard drive as well, and it should open up in R like this. But what we can do with it at this point is mess around with it and change these commands to something that might be useful for us. Okay, as you can see, there's a lot of commands in here, though. What do they all mean? Before I get into that, you can execute the commands in the script in 2 different ways. So we type in a bunch of commands in this document, and then at some point we want to run all the commands just all at once. And the easiest way to do that is to type this command, source sdt script.r. I'm going to do that before too long, so just remain patient with that a bit, but you'll see an example before we get to the end of this. And another command is to use the menu command, which is to go File, Source File, and then if you do that, you just double-click on the script you want to run, and it will run it for you. Unfortunately, that's the ideal case. In my experience, when I do that, sometimes it just screws everything up in R and I have to restart everything. So I normally find it easier to just type this command into the R console. And like I said, we'll get to it before the end of this video. I've got this comment here about changing your working directory to be the directory with the R script and the SDT data in it. And then also the script is set up to output the results of the tests you run in it to a text file called homework7results.txt. So after you run this script, the file will magically appear in your working directory. You can open it up and look at it in a text editor or Word document if you like. Otherwise, you can just satisfy yourself with the output of the script that will appear in the R console on your computer screen. You'll see what I mean by that in a second. To kind of convince you of the magic of this, I'm going to delete this homework7results.txt file and just show you how it magically appears by the time we actually run the script itself. So it's gone now. We don't need to worry because we can generate it automatically. It's not worth that much. I also want to show you another little piece of magic here. I just opened up this R console, and if I type this ls command, it's going to show me what sort of data structures are in my working R console. And basically what I have here is nothing because I just started it. But I'm going to be able to quickly add things as I go using these commands in the script. Okay, so, right, this is not what I want to show you at all. Sorry about that. And instead, what we have here is some comments on what you have to do for this exercise. So the sdt.txt data file contains the response data from the infant adult-directed syntactic disambiguation task I discussed in class or in the previous lecture video I just made. So in this experiment, listeners heard syntactically ambiguous phrases like the peach colors on the wall and had to determine whether peach colors was an adjective noun sequence, like the girl walking into the room with the peach colors on the wall, or a noun verb sequence like the anthropomorphic peach coloring on the wall. A secondary task in the experiment required listeners to determine whether the phrase they heard had originally been spoken to an infant or to an adult. In addition, there were two groups of listeners in this experiment. One group heard the original unedited stimuli, while the second group heard only edited stimuli. To produce these edited stimuli, the durations of the syllables were transferred from the adult-directed speech tokens to the infant-directed speech tokens and vice versa, while leaving the remaining segmental and F0 cues intact. In the R script, these two listener groups are split into the no-switch and switch datasets, respectively. So this is the data we have to work with. There's a lot of different sort of fields in each line, I guess you could say. They're all labeled up here to explain what they mean. And as you see, there's a lot of data throughout this whole data file because there were a lot of different subjects that ran in this experiment in all the various conditions. Okay, we'll get to that in a second here, but that's the basic shtick of this experiment, is that we have kind of three factors we need to worry about: the infant-directed versus adult-directed speech, the two different syntactic types, and also the fact that we have raw recordings of people producing these sentences for adults and infants. And then we have another set of stimuli where we switch the durations between the adult-directed speech and the infant-directed speech. And that last bit is the no-switch and switch data sets, respectively. So the columns in this data file show us the following for each trial that was run in the experiment. So we have observation, which is the unique identifying number for each trial. We have switch, which is whether the listener for the trial in each group was in the switch group or the no switch group. So that's a 0 or a 1. I don't know if I'm going to actually walk you through all of these variables because I am a little bit limited on time. But this is just for your reference's sake in case you're wondering what some of these things might mean. It just winds up being a little bit hard to read in this format in a text file on a web page because the headers don't necessarily line up with the actual data fields themselves. Kind of the interesting part for what we need to do, we have target, which is whether the utterance was spoken to an adult or an infant. We have syntax, which is the syntactic structure. The ambiguous phrase is uttered either AN or NV. We also, as I mentioned before, have switch, which identifies whether the listener for the trial is in the switch group or the no switch group. And then we also have the responses. So the syntactic response is the listener's response for the syntactic identification task, which is this variable here. And then on top of that, we have whether or not those two match with each other. So 1 is if they do match with each other, and 0 is for no, they don't. In other words, 1 is if they got the syntactic structure correct in their response, and 0 is if they didn't. And then there's also, likewise, the target response, which is whether they identified the stimulus as being spoken to an adult or to an infant. And then I also calculated whether the target matched the stimulus or not. If they did, they get a 1 for correctly identifying the target, and they get a 0 for no. And those are down here at the end. There's a lot of numbers. You don't have to worry about them too much because R is going to be able to sort these out. I'm also going to point out there's repeats data too, which is how many times people replayed the stimuli before giving a response to the experimental question. So your tasks for this homework are to first generate values of D prime, sensitivity, and beta bias for each listener for both target types, ADS and IDS, in both stimulus conditions, switch and no switch. And guess what? This is the case. This is the part where I've done most of the heavy lifting for you, or where the script, as it already exists, does most of the heavy lifting for you. As I say it here, it lays the groundwork for these calculations for you, but there are crucial parts of the script that you need to fill in yourself, and these have been highlighted and commented so they look like this. And so this part down here has these little question marks, and if you don't get rid of the question marks in these commands, the script is not going to work. It's just going to give you error messages, and you'll be very frustrated. So with this in mind, I want to walk you through kind of the basics of what's in this script so you can see how you need to change it. So to begin with, like I said, we open up a file for outputting the results of our commands. That's called homework7results.txt. Secondly, what we do is we read in the data file from the local directory, and this is why you need to have this data in the working directory where you're going to run this R script. Put them all in the same spot on your machine, and it's just going to read in this sdt.txt file for you. That's going to all go into this data frame called raw. From that, we create separate data sets for the no switch data and the switch data using commands that we are hopefully familiar with by now. There's a few interesting little commands here which we haven't seen before, which will basically calculate the number of unique subjects in both subsets of the data. And the reason why we're doing this is because I want you to calculate different values of sensitivity and bias for each listener. So ultimately we're going to get, say, in one analysis we'll have measures of D prime for listeners from the no switch condition, and then measures of D prime for listeners in a switch condition, and then we can just run a t-test comparing their D prime values with one another to get a sense of whether they're significantly different or not. So I believe there are 20 subjects in each group. I could be wrong about that, but ultimately you're going to get 20 different values of D prime and beta for each listener, depending on what conditions you're looking at in your analysis. What we have next is just what we call in programming just declaring variables. So I'm creating a lot of different vectors here, which are going to count up basically the number of stimuli that were presented to listeners in different conditions, and then the number of responses they gave to those stimuli in different conditions. So everywhere you see this vector being made, we kind of don't have to worry about that. That just means we're going to create an array with a label that looks like this. And there's a lot of information in these labels. I'll show you what they mean down here after this whole declaration of variables phase. There's also variables being created for D prime and bias or beta for the different conditions. So whether it's switch or no switch, and then whether they were listening to ADS stimuli or IDS stimuli. So we wind up with 8 different vectors being created that way for both types of variables and also the 2x2 condition sets. Going down here, I'm actually calculating the kind of grunt work that you need to do for this. So this is one of those for loops, and this is where that number of subjects comes into play. So it's going to go cycle through every single unique subject in the data that it has, and then it only closes off this loop down here. So this first loop is for the no switch stimuli. So every single variable here has no switch at the beginning of it. And what I'm calculating here, there's a lot going on in these commands. You don't have to worry about it, thankfully enough. What it will do, though, is it will take, say, look at only the no switch stimuli, and then it's going to filter it into the number of responses, or sorry, this is looking at all of the AN stimuli for the no switch condition, and then it's counting the number of AN responses we got to those stimuli, but only for the adult directed speech tokens. And if you walk through all the different sort of logical conditions we're applying here, those will match up to what the variable name says. So the syntax is AN here for the original, for the stimulus. The response is also AN. This is directed towards an adult listener. And then the listeners are specified as being part of the no switch listeners here as well. So that's all I'm going to say about that. This is counting the number of AN responses we get to AN stimuli. I also go through and I count the total number of AN stimuli that you get for the adult-directed speech, so on and so forth. So ultimately, we just have to count these things up. And this is a way of creating one of those confusion matrices, basically using R commands. So if we go down to this next, if we go down to this next example, it'll do the same thing, but you can see how there's basically 4 totals that we'll create here for each of the different stimulus and response combinations. So this is AN stim, AN responses. This is AN stim, NV responses here, and then there's NV stimuli, and then AN responses and NV stimuli and NV responses. So you can think, you have to figure out what means what here, but you can think of whether these 4 are going to basically give our hits, misses, false alarms, and correct rejections, right? And then we also are totaling up the number of stimuli in each row in our confusion matrix with these commands here. So this tells me how many total AN stimuli there were, and then this tells me how many total NV stimuli there were. What I'm not doing here is calculating proportions or percentages of these totals. So I'm not going to give you directly the proportion or percentage of hits or the percentage of false alarms, that sort of thing. You have to figure out how to do that yourself. There's also some code here that deals with these sort of limits of the perceptual responses that we have in a confusion matrix. So if you have a total of 0 for one of these sort of response options, then what it does is it adds 0.5 to that total. And if it isn't 0, then it just keeps it the way it was originally. And then if you have a sort of 100% total in any given box in the confusion matrix, like here, then it will subtract a total of 0.5 units from that, and if not, it just leaves it the way it was. So I talk about that at the end of the signal detection theory lecture as well. We kind of need to just back off from those 0 and 100% limits, otherwise this thing won't work. But again, lucky you don't have to do any of this grunt work because I've done it for you, but the part that will cause you a little bit of headaches what are these commands down here. So given all of this, all these variables here, I want you to calculate D prime for the individual subjects in the ADS and IDS conditions, and also D prime, also bias for the individual subjects here. And basically all you have to do, as it says, is that your job is to insert the correct equations for D prime for the no switch subjects for both types of stimuli, ADS and IDS. So the equation is going to look fairly similar, and you know what the equation should be from the lecture notes as well. All you have to do to put the equations in here is replace these question marks. So eliminate these question marks and put some equation in there that makes sense and works for the data that the sort of data structures I've created for you here, and then your job is done, at least as far as this goes. Yeah, so if you leave these question marks in here, the whole thing won't work at all. So it'll give you an error message and you won't get anything out of it. I'm going to show you what happens when you do put something in those question mark spots. Before I do that, though, I'll point out here at the bottom that there is some R syntax that will basically run the relevant t-test for you, and then also spit the results of that t-test out to both the screen and also to the homework 7 results.txt file. So you don't need to worry about all this stuff too much, because again, I've done it for you. And then there's a command here that closes off the file, so on and so forth. You can look at this stuff if you would like, but mostly what you will have to focus on is this line here. You will have to change this to run different t-tests as you go through the different sort of comparisons that we're going to have to worry about for this homework exercise. So this won't be able to stay the same the whole time. Or you can, if you feel adventuresome, copy and paste this one and sort of create multiple t-test commands here. Let's say this one goes in the t2. Actually, I'm going to recommend that you don't do that, because then you have to worry about all the rest of these commands here. So only do that if you feel adventuresome and like you're an expert of some sort with scripting. But otherwise, just change this t-test command to get the different t-tests you want. I'm going to leave it as it is for now. I'm going to show you an example of what it looks like when this thing actually runs. And the way I'm going to do that is I'm going to put random numbers into my d prime arrays and my bias arrays. So I'll just put a random number from 1 to 100 everywhere I see question marks. And again, what this does is we're cycling through the data for each subject independently. So there are 20 subjects in each group. So what I'm going to wind up with here are 20 d prime values. But in this case, they're just random numbers from 1 to 100. And then I'm going to wind up with 20 bias numbers as well. So let me do that for this part here, which is the data for the switched stimuli. And it's still going to run the t-test down here at the bottom, but it's basically comparing random numbers with each other. So I'm going to save that for now, even though I don't really want to. It's just for demo purposes. And like I said, I will show you what it looks like when you run it. And for that, we'll go back to this command here at the top, this source sdtscript.r, but I'm not going to run that particular command because the oops, I'll just type it, because I'm actually using the script with the comments in it. So I'll run sdtscript with comments.r, if I can type it. So it's this file name up here. And all I have to do here, now that I'm in the right directory and I have my script modified the way I want it, is I just hit return. And lo and behold, it just takes half a second, right? And then all of a sudden it spits out these t-test results at me. So these, again, are just comparing random numbers with each other. So my p-value is almost close to 1 because they're basically the same. It's like 53.75 and 53.94. But it gives me the mean values for the switch and the no switch subjects. It's going to look different when you do it because you're going to actually calculate d prime. And then when you want to calculate bias, you're going to have to change or run t-test for bias. You're going to have to change this d prime part here to bias, right? And for the relevant group of listeners. That's basically all I have to do to run that different t-test. I'm not going to do that right now. I'm just going to show you one thing that happened here, or two things that happened. So if I type in this ls command again, all of a sudden I will see there are a lot of data structures that just appeared in my R console that weren't there before, right? Before I ran the script, there's nothing. Now I have all this stuff. Let's take a look. Let's say d prime no switch ADS. No, I don't want to show that because that'll give away the answers. Instead, I'm going to show you no switch and stem and response ADS. So this is all the number of times that people heard AN stimuli and then responded with AN for the adult-directed speech. And what we see here is a string of integers, or mostly integers. Looks like we had to make a patch here for one of them. But there's different numbers. So this is basically counting how many times each subject gave this response type to these stimuli for the ADS condition. Subject 1 gave it 22 times, subject 2, 24. You can also compare that to the total number of stimuli they heard in that condition, and it's 36 across the board, right? So this first subject had 22 correct hit responses out of 36 for this stimulus type. The second one had 24, so on and so forth. This poor person had 0, so they kind of had to get bumped up to 0.5 just to make the math work for D prime calculations. But that's what this is showing you. And based on these numbers, you should be able to calculate 20 different values of D prime, one for each subject, knowing what these sort of correct responses are, and then also ultimately what the false alarm counts are too. And I'm going to let you figure out how to do that. But I will say, once you figure out how to do all that, go back to the homework. That's just part 1. Part 2 is that you need to run those t-tests. Oh, and I forgot to show you, our t-test results magically appeared here in our directory. Remember, I deleted this file before, but now when I double click on this, it shows me exactly what the R console showed me the same results, right? So now I have a record. I don't just have to store it here in my console, although I could save it that way too. Yeah, so run t-tests to determine whether the sensitivity and bias numbers you've calculated are significantly different between the two groups of listeners, the switch listeners and the no switch listeners. You should run separate tests for the ADS and IDS data, so this will require you to run 4 t-tests in total. So 2 for sensitivity and 2 for bias, and the way that the 2 are separated is 1 for ADS and 1 for IDS. Report the results you derive for these tests in the standard notation, and don't forget to tell me what the significance or non-significance of the test results mean. So don't just say, I got a significant result. That's not good enough. Tell me maybe the switch listeners are doing better than the no switch listeners. Maybe they have a higher D prime or not. Tell me that part of it and what you think it means. Also, because we're going to be dealing with bias, make sure that you can identify what positive or negative bias numbers mean, and with respect to how you define hits and false alarms in your analysis. So just again, the goal of these little write-ups is to make it clear that you understand what all you're doing actually means in terms of the real world experiment that we've been running. Number 3, run t-tests, basically doing the same thing, determine if there are any significant differences in sensitivity and bias between the ADS and IDS responses. And here you should run separate tests for the switch and no switch groups, so this will also require you to run 4 tests in total. So in this case, in part 2, you're comparing switch and no switch listeners. In part 3, you're comparing ADS and IDS stimuli, basically. Maybe I should change this, but this should be the stimuli types rather than the response types. So again, report the results of these tests in the standard notation, and don't neglect to tell me what the significance or non-significance of the test results mean. Also tell me what the bias numbers mean as well when you calculate that. But the important difference between these two is in this part. So here you're comparing the 2 groups of listeners, and in this case you're comparing the 2 groups of stimuli. Yeah, you're going to have to run separate tests here for the switch and no switch groups, so you wind up with 4 different tests as well. And if there's any confusion on that, please get in touch with me as soon as you can once you figure out how to run t-tests with this setup, because I don't want that to lead to any problems on the end result of this. There's also an extra credit task which you can do if you're feeling confident with this, which is where you can calculate sensitivity and bias numbers for the target response data, i.e. how well listeners identified whether the original utterances have been spoken to an infant or to an adult. For these numbers, run one sample two-tailed t-tests. Always by default, please run two-tailed t-tests to determine if the mean sensitivity and bias values in the target identification task are significantly different from 0. And here I haven't done the grunt work for you, but there are these target response numbers in here, and also whether the targets match or not here. So if you really feel comfortable with all of this syntax in the R script, if I can get to it, you're going to have to modify that a bit to give you the relevant data for the target identification task. So that is extra credit for a reason, because it's not going to be easy for you to do that. Although once you get the hang of it, it shouldn't be too hard. It's mostly kind of copying and pasting things and then tweaking them when necessary. So your job there would be to determine if the mean, sensitivity, and bias values are significantly different from 0, which would be basically what you expect from chance. Report the results for these tests in the standard notation and let me know what you think the significance or non-significance of the test results means. Also remember to identify what positive or negative bias means with respect to how you've defined hits and false alarms. I'm not going to say much more about that because that's extra credit, and if you want that extra credit, you got to earn it, basically. Also, if you want an advanced degree in linguistics, you got to earn it too. So for those of you who are grad students, I want you to answer a few other questions. Number 1, what do you think the results of the test show you? Number 2, what effect does infant-directed speech have on the perception of syntactic ambiguity? So you should, I'm not going to explain to you how to answer those questions, but running these tests will help you answer these questions, right? Are listeners more biased towards one response option or another? What effect does manipulating the signal have on the ability of listeners to perceive its syntactic structure or intended target? So this is a question about the sort of switch versus no switch manipulation here. And this is more of a question about infant-directed speech versus adult-directed speech. Okay, that's all I'm going to say for now because I've run out of time. I've actually gone over time. Again, I have to go collect my child from school so that she can interrupt another one of these lectures some other day. Anyways, write up your responses to these questions and tasks in an easily digestible format for me to read. Send me those write-ups in your modified R scripts. So send me what you actually did with this so that I know what you did, that you used to complete these tasks. And also, please let me know if you have any questions. That's basically it. It's due on Friday of next week, October 29th, right before Halloween, so you get the scary stuff out of the way before you can enjoy that Halloween weekend. All right, I got to go. I'm saying goodbye. But again, let me know if you have any questions.